Now let's talk about the drill shaft reinforcement and spaces lock. This form, you will use this form for documentation on a very important part of the shaft, which is the amount of reinforcement that it was used, the actual rebars and tubes that were used in the construction of the shaft. In this particular case, you will see there is some data in the blank cells, which, by the way, you cannot input anything around it. There's nothing you can do about it. It's being imported directly from the first page, as you can see there. Okay. Okay, now you will have some available data to input these persons. Um, you will have a drop down face, drop down arrow if in case you you were the same person who inspected the excavation, then you will input that name, or you input a different name. Let's say you were the name was Mr. Enforcement. If it's a different inspector, so you will input a different name. Okay. Now, based on the cage diameter, you will input the cage diameter. Again, remember, gray is for input. Based on this cage, the computer will give you a suggestion. By the way, don't forget to check these hints. Based on this diameter, the computer will estimate, well, you should be having 5 CSL tubes. Okay. Keep in mind, for example, if I input 72 inches, this is a big shaft, so it's going to change that. You see that? It's going to change that. Alright. Then we will input the length of every CSL tube used in the shaft. Also, you will input the number of spaces. Sorry, not the distance of spaces. For example, check this drawing, check this sketch to verify the distance. D1 is the distance from the bottom of the shaft to the first spacer. D2 is the second distance here between the bottom spaces of the next row, etc. It is the number of spaces per row, and based on the spec, there is given a suggestion here. Alright. This particular case, by the way, it's telling me a number 8 should be 8 because I input a 72, but if, of course, if I input, say, for example, 60, it will be less. Or if I input, for example, 36, it will be less. Right? Right, now it should be 4, and so forth. So let's keep the original, I think it was 42 inches, that was the original diameter I had before. Now, you will input here the number of longitudinal bars. You will have you will input the rebar diameter for these longitudinal bars. The length of those rebars, you will input those. Tie bars. Tie bars, by the way, are these horizontal or these radial reinforcement. Okay, sometimes it's being called lap bars, or I think they may call it even hook bars, but in the spec this is called tie bars. So please keep in mind that one. Now you see some suggestions in parentheses should be 14. So where this is coming from? This is actually this is a suggested number based on, says here, based on the steel volume sheet. Okay, we'll talk about what is this about. Okay, so for those miscellaneous structures, sometimes you have you may have in the plan, so most of the time you will have indices. These dimensions will be ruled by indices. So we'll talk about this one later on. They will just be used as a guide to basically verify whether the contractor is using something that resembles whatever is indicated in the indices. Other additional questions, just, if the bottom was extended, just reply, whether it was extended or not, and, how many bars, and how much it was extended, and so forth. And this is a checklist. Make sure, verify that all the cross ties, all the rebars intersections were tied in accordance with the specs. This little square here, this little block here, is computations. The computer will compute on the total estimated volume based on the data you input here. It will consider the volume of the CSL tubes or access tubes. It will estimate the volume of the rebars. So that would be part of the total steel cubic yards in the shaft. And that's something basically that we're going to use later on to correctly plot the volume, the concrete volume versus depth.